Okay, so at the top of our notes, we have these different inequality symbols. This is a less than symbol. So for example, we could say x is less than 5. And for some of these examples, I'm just going to write it out in words. And for some of these examples, I'm going to draw it. So x is less than 5. I'm just going to write this in words. X is less than 5, so that we know how to read it out loud if we need to. The next one, we're going to do x is less than or equal to -2. This one we're going to draw. So if we had x is less than or equal to -2, we would draw it on a number line. So here's -2. I would draw a circle on the -2 and I would fill it in because you can equal -2. And then to be less than or equal to -2, you would just make sure that the arrow goes to the left. So if you have your little number sentence like this, if it's written so that the variable is on the left side, then this symbol and the arrow match. So less than is a left arrow. So x is less than or equal to -2. Next one, x is greater than 1. So I'm going to go ahead and draw a picture for this one also. So if we've got 1, I would draw the circle. If it's greater than 1 but not equal to, then I should not fill in the circle. And my arrow should be going to the right because it's greater than. Would look like this. And then last, greater than or equal to, x is greater than or equal to 3. X is greater than or equal to 3. All right. Anytime you multiply or divide by a negative number, you have to flip the inequality symbol. So multiplication and division specifically, not addition or subtraction. So if you multiply or divide by a negative, that's when you flip the symbol. So we're going to go ahead and force the first example to do that so that we can see what happens. So even though this is not the only way to do example 1, I'm going to start by adding the 2m to the other side. I know that some of us manipulate problems so that our variables are always positive, so that our coefficients are always positive, which you can definitely do and still get the answer right, but I'm manipulating the problem so that it does exactly what I was talking about before. So if I add the 2m to the other side, that means I have a negative 2m plus 6 is greater than or equal to 14. And then what would I do next? Not the 14. So yeah, subtract the 6. So you could subtract the 14, but you'd have everything on the same side, and we typically want things to be on both sides. So I'm going to subtract the 6 over so that I've got my variable on one side and my numbers on the other side. So negative 2m is greater than or equal to 8. Okay. So negative 2m and 8. And then what should I do to get the m all alone? Divide. So here's where we're dividing by a negative, and since we divide by a negative, when we write our final answer, we have to flip the symbol. So I'm going to have an m, and instead of having a greater than or equal to sign, I'm going to have a less than or equal to sign. M is less than or equal to negative 4. So there's my solution. The instructions also ask me to draw my solution on a number line. So I'm going to go ahead and do that as well. So we're going to look at negative 4, right? And then because it says equal to, we do a closed circle. Because that's what the equal to means. Closed circle. Good question. And then we have the m. The arrow goes to the left. Less than. So we're looking at all the numbers that are smaller than negative 4 or more negative than negative 4. And there's our solution. Any questions? Okay. All right, how should we start number 2? Yeah, combine the negative 7 and 24, and then we can do what you said about subtract the 6m. That's not a bad idea. So first, before we start getting the m's to one side, we do have some like terms to combine. So a negative 7 and a positive 24 gives you what? 17. Okay. All right, and then we can subtract that 6m. So negative 3m minus 1. And then what should we do? Add the 1. Okay. So negative 3m is less than 18. What should we do now? Divide by negative 3. So we have m and negative 6. And which direction should the symbol go? Greater than. Should be a greater than symbol. So we switch the directions. Okay, and then we have to draw a picture of our answer. So should we fill in the circle or not fill it in? Don't fill it in because it does not have an equal to. And then which direction should the arrow go? To the right. Okay. How should we start number 3? The parentheses. We distribute the 2. So when you distribute the 2, what do you get? 2 2 minus 14k. Okay, the left side is going to stay the same. All right. What should we do? Why couldn't we combine those? Can you tell? They're not like terms. So one has a variable and one doesn't, which is what kept us. Okay, so we can add the 14. Do you mean this 14 or this 14? The one with the k? Okay, so we're going to add the 14k. Add the 14k. So how many k do we have? We have 8k. So negative 14 and positive 8k. And then what should we do? Add the 14. Okay. So 8k is greater than or equal to 16. And then what should we do? Divide by 8. Do we have to flip the sign? No. Yes? No. Why not? Yeah. Yeah, it's a positive 8. So no need to flip when it's positive. Okay, so k is greater than or equal to 2. Okay, there's our solution. And let's draw it. Should I fill in the circle or leave it open? Fill it in, okay. Which way does the arrow go? To the right. Okay. All right, we have one more example. How should we start it? Okay, so distribute the negative 2. And what do we get? Okay. Is it going to be what? You're close. It's a weird one though, right? How do we know this one's weird? Yeah, it ends up with like something. Something is funky about it. So let's go with it and see what happens, because when things go funky, the answer could either be no solutions or all solutions, and we have to see which one. So let's start, because some people might not have noticed. So let's start by doing the same thing we would have done for the other problems, so we can see how people were noticing that this one was weird. So if you try to get the ends on the same side, what would you do? If you were trying to get the variables, if you're trying to get the ends on the same side, you would add 2n. And that's when you start to notice that things are getting weird. Because when you add the 2n's, what happens? Yeah, the variables go away, right? So whenever you have a problem, and this is the case for inequalities, but it's also the case for equations. Whenever your variables disappear, that's when you say, okay, something weird is happening. My answer is either all solutions or no solutions, okay? It's going to be all solutions if what you're left with is true. It's going to be no solutions if what you're left with is false, okay? So if you're left with something true, all solutions. You're left with something false, no solution, okay? So if we look at this, is negative 16 greater than or equal to negative 16? Is negative 16 greater than negative 16? No. Is negative 16 equal to negative 16? Yes. This is a true statement. And if it is true, what does that tell us? All solutions. Okay, so that means you can plug in any number that you want for n, and it will work every single time. It'll just give you that the left side of the inequality and the right side of the inequality are the same number. That's what's going to happen every single time. How do we draw all solutions on a number line? You draw the arrow going both ways. The whole thing is dark. The whole thing is drawn in. How do you draw no solutions on a number line? If you did a circle, would it be filled in or not filled in? Wait, what does filled in mean? Yeah, so filled in means that you can equal that number. So if we said no solutions, we would not want to be filled in. So if we have an all solutions answer, negative 2, 2, we're going to want this whole thing to be dark. Make the whole thing dark. You can put a dot on there if you want to have a dot somewhere, but you don't need to because there's not one specific answer that we're looking at. So the whole thing's going to be dark. And then if we had no solutions as an answer, you would just have a number line with nothing on it. Does that make sense? Okay. All right, so what we're going to do is I have an escape room activity for you guys, and it has 3 levels to it, and I did a teacher no-no where I did not make an answer key ahead of time. I'm assuming that this escape room works out perfectly. So it has 3 levels, and the problems get more difficult with each level, and then when you're done, you're supposed to be able to show things to me and get a code, I think. I don't know. I'm going to be one step ahead of you the whole time. That's the plan, okay? So I'm going to give each group all of the things for the escape room. It is not a race. It is not a race. If you want to make it a race, that's fine. But it is not supposed to be a race, okay? Your goal, however, class goes until 1:35. Nope. Yes. Yes. Yes, 1:35. I used to have second lunch, and that is based off me having second lunch, so I need to fix the whiteboard schedule. So class goes till 1:35. We're going to see how much of this we can get done before the end of the period, and then by the end of the period, I will tell you what your homework is. I might have to put some of this on Google Classroom so you can access it for homework, okay? All right, so let me go ahead and get this handed out to the groups. You will need